Good morning. Today we're going to do the lecture live instead of doing it because of the sound issues. So I'm sitting in the classroom over here at Cisco. I am in classroom 10 because 7 is locked and I don't have a way to get in. So remember, first things first, go in and into the chat and type your name in the chat bar so that I can count you present for the day. And then we're going to get started with chapter 3, which is sensation and perception. So I think that we're going to have to start doing the lectures live every week because I could not ever figure out why the sound wasn't working when I would try to show the video. So it's all good. We'll figure that out.
Marina, are you doing anything? Okay. Well, my earphones won't work, so my Zoom's on. Okay.
Okay, so today's Thursday, September the 10th, and we are going to go over chapter 3. I sent out a few emails yesterday regarding discussion 1 and the syllabus quiz. If you got an email in Canvas yesterday, please make sure that you take that syllabus quiz if you have not taken it, or also post to discussion 1 if you haven't done that yet. Because, let me mute everybody. Those close tomorrow, September 11th, Friday at midnight. So if you have not done discussion 1 or the syllabus quiz, you might remember originally the due date was September 4th, but I changed that because of some issues. Okay, so today we're going to go over chapter 3, which is sensation and perception. Okay, the differences between sensation and perception. First and foremost, sensation is, as you can see, the activation of the receptors in the various sense organs. So we know we have vision, hearing, smell, taste, and touch. Those are our basic senses. We're going to talk about a few more in there. And so at our sense organs, like for instance, our eyes that we're going to talk about in just a minute, we have certain cells that are called sensory receptors. So in our eyes, they are the rods and the cones. So those sensory receptors are going to take outside energy that's going on all around us in our environment, and they are going to turn that outside energy into a neural impulse. This is called transduction. So when we turn outside energy into a neural impulse, this is called transduction. So we're going to talk about all of the senses and where transduction occurs at each sense. So I also want to tell you that when looking at sensation and perception, you can think of sensation as gathering the raw data, so everything that is true and real that's happening outside of your body, and perception is how you interpret that data. So when we're looking at sensation and perception throughout the semester, because we will be revisiting sensation and perception at various times, you need to remember that perception is very unique. Okay, I'm not understanding. Hold on. Perception is very unique. So each person is going to perceive things differently based on their own experiences. So perception is based on experience. So let's talk about sensation first. So there are a couple of things going on with sensation. I told you that sensation is the activation of the sense organs. Well, there are a couple of things that we need to talk about regarding sensation itself. First of all, the just noticeable difference. This is the amount of energy needed for you to detect a change in the stimulus at least 50% of the time. That's called just noticeable difference, okay? For instance, if you're listening to music in your car, you're driving down the road, you have the radio on, how much do you have to turn that knob, the radio volume knob, in order for you to notice that there is a difference in the loudness, if you will, of that sound? Okay, so speaking of just noticeable difference, there is a law called Weber's Law that says that there is a relationship between the original stimulus, the amount of energy exerted from the original stimulus, and how much of a difference is needed. So if there is a lot of energy exerted, then it's going to take a big change for you to notice a difference. So that means if you're listening to the radio really loud, you're going to have to turn the knob a lot to notice a change in the volume of the music. But if you're listening to the radio very softly, then you're only going to have to turn the knob just a little bit in order to notice the difference. So the just noticeable difference is related to Weber's Law, meaning that there is a relationship between the amount of the original stimulus and the amount of change needed for you to notice a difference. Okay, now I should have talked about the absolute threshold first, but now let's talk about the absolute threshold. The absolute threshold is the smallest amount of energy needed for you to notice that energy is present, at least 50% of the time. So there are things going on all around us that you don't hear, that you don't see, that are in existence, but they don't exert enough energy for your sensory receptors to pick up that energy at least 50% of the time. So there's always been a big, there's subliminal, let's go to the next one. Subliminal perception, you've probably heard about this before, is when the energy that is exerted by the original stimulus, let me see what the chat says, does not cross that threshold. I'm not seeing my chat. So if somebody has asked a question, I don't know why my chat's not pulling up. Okay, somebody just typed their name. Okay, so there has actually been research done on subliminal perception. You might have heard that if you record like your lecture notes and you listen to them at night whenever you're sleeping, that helps your brain to absorb that information. That's type of subliminal perception has never been proven. So they even have done a study like way back where they would be showing at a movie theater, they would show flashes of Coca-Cola and popcorn. And of course, the people that were selling the Coca-Cola and the popcorn really, said that this works, this helps you, even though you don't notice it fully, it does play on your perception, but we know that all of that has been, it has not been proven. So there's really no such thing, if you will, as subliminal perception. Okay, so let's talk about some things that go on with sensation that are actually kind of unique. The first thing I'm going to talk about is habituation. Habituation is when your brain stops attending to constant, unchanging information. For instance, if I could see your faces and everybody has the recording off and that's fine, but I'm going to ask a question and if we were in class right now, I would have all of you raise your hand. So I'll just wonder how many of you out there sleep with a fan? I'm sure that a bunch of you do. We do. My daughter and I sleep with a fan. Even when it's cold, we had the fan going. I cannot pull up my chat, y'all. Let me see.
I do. I sleep with a fan all the time.
Okay, who said that?
Abigail Weaver.
Abigail, yes. And it helps you sleep better, doesn't it?
Yes.
I'll tell you.
I can't sleep without one.
I can't either. It's like we have to have a fan, and in the mornings when I want to wake up.
I have a noise machine and a fan and my air conditioner.
Yes.
And I still can't sleep. I'm an insomniac. And then I have to
Oh, gosh.
put me out.
I cannot sleep without one. Presley says that. I only do sometimes, Rebecca. Okay, Rebecca, I'm curious. So you only sleep with a fan sometimes. How? Talk to me. Turn on your turn off your mute and tell me about that. How does that work?
I only really sleep with a fan on when it gets super hot in my room, and like if I like end up needing noise for it.
Mm-hmm. Okay, so let me ask you a question, Rebecca. You said if I end up needing noise. What's that all about?
Sometimes I'm
Noise.
super tired enough to like where I just go to sleep.
Uh-huh.
And then sometimes I can't fall asleep, so I have something that just lulls me to sleep like that.
Lulls you to sleep. Yes. Let me tell you all what's happening, and let me tell you all why you're doing that and why I do it. Casely and I sleep with a fan on. Even, you know, it was cool in our house last night, and we still had to sleep with a fan on because that constant unchanging noise, our brain stops attending to that constant unchanging lull, as Rebecca said, of the fan. However, that constant unchanging noise is going to block out all of the sounds like of the barking dogs. We live right next to the fire station in Albany, so you know, if anything, if a fire truck goes out or whatever, all of that noise is blocked out by the fan. But because of habituation, the noise of the fan doesn't bother us or keep us awake. So some other things going on with habituation, a change in sense. Okay, so Derek, I don't know if you know the Hefners, Charlie and Tinley and Howdy Hefner, okay? But there's some kiddos in Albany, and they're kind of like my second kids. Charlie's on the same softball team as Casely. So a couple of weeks ago, we had a tournament in Midland, and Howdy went with us. And Howdy is hilarious. He is a handful. So we get, you know, between Big Spring and Midland, and Howdy starts yelling at me like, I mean, pardon me saying this, but he was saying, Tara, you farted. Tara, you farted. And I was like, no, Howdy, I did not. That's the smell of the oil. If any of you have been to West Texas, you know that there's this pungent smell that is actually the smell of the oil. So that after 3 days of being in Midland, we didn't smell that pungent smell anymore because
I remember like Avondale. It was like at the paper mill. Every single time you go past that thing, it'll be like,
yeah.
I remember I grew up near that. I was born and raised in East Texas. It's worse because there's always trees. They traps the smell, and then it's like the wind, and depending on which way it goes, it's surrounded by power plants and all kinds of power plants.
Same thing. That's the same thing. But after being in Midland for 3 days, and Phoebe, you might have recognized after a while you stop smelling that smell because our brain stops attending to that. Well, this is habituation. So this is how habituation works. So your brain will stop attending to that smell. It's the same thing I do in my house. I have a little Scentsy burner, and each time I change out the Scentsy wax, I put a different scent in, because our brain gets used to smelling a certain scent and we don't smell it anymore. So that's habituation. Habituation, remember, has to do with the brain. So habituation is when the brain stops attending to information. Sensory adaptation is when your sensory receptor cells stop firing. So if we did not have sensory adaptation, our clothes would drive us crazy, because we could feel our clothes, we could feel our glasses, and that would probably drive us crazy. But after a while, you don't feel your clothes and things anymore. Okay, so let's go. Let's talk about the sense of vision. So I have an eye here. So what we see is wavelengths. So in our environment, there are all sorts of wavelengths. What we see is on the visible spectrum. This simply means that the wavelengths are the right size for our eyes to interpret those wavelengths. So the wavelength size, like how tall it is, how wide it is, that's all gonna have to do with brightness and saturation and color. Okay, so let me tell you how this works. So if you see the PowerPoint here, it says light, because it is light energy that we see. That's the visible spectrum. So light is going to pass through our pupil and be focused in the lens, and all of these, there are all sorts of anatomical structures here, but what we are mainly concerned with is back here in the back of the eye, the retina. Okay, on the retina, there are two types of cells. There are rods, you've probably heard of this before, rods and cones. Rods and cones are going to transduce light energy into a neural impulse. Rods are going to transduce black and white light energy, or lack thereof, because black, remember, is no light. Cones are going to transduce color. So after the rods and cones turn that light energy into a neural impulse, it is going to travel out of the eye via the optic nerve. And then if you remember from chapter 2, it's going to travel to the back of our head, to the back of our brain, the occipital lobe, okay? So it will first stop at the visual and primary visual cortex, and this is where all of the sensations are gathered. All of the raw data are gathered. And then it's going to go on to the primary visual, to the visual association area where you perceive it. But I want you to understand that you do not perceive raw data, if you will, because so many other brain areas are playing on everything that's going on outside of you. So all of this raw data is sensation, but your perception of that raw data is going to depend on your experience and going to depend on your own unique everything that's going on with you, okay? So other areas of the brain are actually gonna play on that vision. So let me give you an example. Purple's my favorite color. So if I were looking out into the visual field, I would probably notice something purple before I noticed anything else. That's based on my own unique experience and the fact that purple's my favorite color. Okay, so speaking of color, how do we see color? I told you that the cones are going to transduce color energy or color light. So think about it. If you don't have any cones, what condition might you suffer from? Does anybody know?
Color blindness.
Color blindness, yes, thanks Ace. Color blindness is, there's different,
By 2 seconds.
there's different types of color blindness. There are monochromats and dichromats. So monochromats is when you don't have cones, when you only see in black and white. Dichromats is when red and green is slightly confused. Okay, so when we talk about red and green, let's go on and look at, sorry, I don't know what that is. Let's look at color vision. So the trichromatic theory of color vision says that we basically see 3 types of colors, red, blue, and green. And it's a mixture of all of those 3 colors that helps us to see color. This is a little bit more complicated than what I'm just throwing out there to you, but for this class, just know the trichromatic theory says we have 3 types of cones that see red, blue, and green. But then we look at another theory called the opponent process theory. This says that there's opposites. So red and green are opposites, so you'll never get like a reddish greenish color, and blue and yellow are opposites. So if you know anything about old school photography, okay, so nowadays we use our phones mainly to take pictures, but whenever I was growing up, we would go buy these disposable cameras from Walmart, and we would then have to take film to be developed. So the film is called a negative. And basically what's happening is the neurons that are excited by red light energy will eventually tire out, and so you will see green. So it's like if you are looking into your visual field, like I have, this disinfectant stuff is sitting here, and I see this red part of the bottle. If I'm looking at that and then I close my eyes, I kind of see a green outline of this exact same red thing. So there's a great example in your book. That stuff stinks and it leaked on me. But anyways, there's a great example in your book if you check it out. So everybody just take a second to stare at that white dot. I'll tell you when to look up. So stare at the white dot in the middle of the flag. Okay, now close your eyes or look up at the ceiling or something white. Did that work for anybody? Do you see the red, white, and blue flag?
Yes.
Isn't that cool?
Oh, I love that. Oh, my internet connection's unstable, so you kind of keep going in and out.
Well, that's because this is because of the opponent process theory. So red and greens are opposites. If you're staring at something green, it's going to tire out, and when you look away, you'll see red because that activates the red neurons. So what theorists propose is that it's a combination of the trichromatic theory and the opponent process theory that helps us to see color. So anyways, now let's move on to hearing. So let's look at this all these little pictures of the ear. So this part of our ear, what we call our ears, that's the pinna, and it's shaped perfectly to catch the sound waves out of our environment. And then those sound waves are going to travel through the ear canal and vibrate the eardrum, which in turn is going to vibrate the three smallest bones of the body. They're called the ossicles, okay? The hammer, anvil, and stirrup. And see them right here, they're bigger. And they're gonna continue to vibrate. You see, here's the cochlea. The cochlea is the snail-like thing that is going to be filled with fluid. And there are other types of nerve cells in that cochlea, like hair cells that will bend. And when that bends, it's going to send a transduce those sound waves into a neural impulse. So this is where transduction occurs. And then it's going to send that neural impulse to the temporal lobe of the brain. So the temporal lobe, the primary function of the temporal lobe is for hearing. Okay, so just like in vision, the first stop is going to be the auditory or the primary auditory cortex, where all of the loudness and tone and everything is gathered. And then it's going to go on to the auditory association area where you perceive that sound. Okay, so here's an example of how perception is very unique. If I was in a crowd of people, which of course we know that's not going to happen right now, but if I was in a crowd of people and someone yelled out Bill, I probably wouldn't turn my head because Bill is not my name. But if I was in a crowd of people, I was at the fair on Monday night. I took my daughter and her friend to the fair on Monday night. And so I'm standing there and all of a sudden behind me, I hear Tara, Tara. So I turn around and it was actually two of my Eastland High School students. So shout out to Isaac and Jillian. They were at the fair and I heard my name and I turned my head. So that's an example of how perception is very unique and is based on our own experience. So I want to talk about something while we're here looking at the picture of the ear. It's these three semicircular canals, okay? They are filled with fluid. You'll notice how they're kind of angled differently. They are responsible for our vestibular sense. Okay, this isn't one of what, you know, when we talk about the five senses, we don't talk about the vestibular sense, but your vestibular sense is your sense of balance in, you know, when you're standing up or whatever. You might have noticed that if you ever had a severe ear infection, that you were a little bit dizzy. That's because the semicircular canals were affected and it causes you to not really be fully in tune with your bodily position in the environment. So that is important to look at as well. Okay, now let's look at the sense of taste. The sense of taste is also called gustation. Okay, so on our tongues, we have little bumps. Those are called taste buds. On the taste buds, there are things called papillae that is going to take the chemicals in the food and transduce them into a neural impulse. Okay, different areas of our tongue are responsible for transducing different tastes. We have 5 basic tastes. That's sweet, sour, salty, bitter, and umami. Umami is a Japanese word that means savory. Okay, so that's going to be things like pizza, all the good stuff. We are innately drawn to or attracted to sweet and salty flavors, and we innately avoid sour and bitter flavors. So this is because of probably survival, because in primitive times or in primitive cultures, if you were to eat a berry and it's sour, chances are that berry could make you sick. So you want to avoid the sour berries. Of course, I love sour candy. So you say, how can we want to avoid sour food, but I eat lots of sour punch straws? Well, that's just because we have adapted to that sour candy and we learn to like it. That's something that's very unique, a very unique perceptual concept based on experience. Now, we cannot mention gustation or the sense of taste without mentioning olfaction. Olfaction is our sense of smell, because taste, you might have noticed that if your nose is stopped up, you can't taste your food very well. So the sense of smell is very unique and it happens very quickly. And if we were in class and we were just chit-chatting, I would ask the question again, why would the sense of smell be so unique and happen so quickly? And your answer to that again would be survival. As you can see, whenever we smell volatile substances. A volatile substance is a substance that gives off chemicals at room temperature. So those chemicals are going to travel up through our nose and are going to immediately be transduced by the hair in our nose and interpreted by the olfactory bulb. It's part of the brain that very quickly transduces the sense of olfaction, or what we're smelling. Okay, so let's talk about how smell is related to survival. Okay, so I know that when Casely was a baby, she had a very unique smell. And it wasn't like a baby powder smell. It was very unique, and I was very attracted to Casely's smell. And they also say that babies are very attracted to their primary caregiver's smell. Okay, so that probably has something to do with survival. Secondly, you can usually smell like a fire before you can see it. So it's a warning sense, and it tells you that something is going on. So I'm very thankful for how quickly the sense of smell works. If there's something dead or pungent going on, you want to avoid that. You know, you may gag a little bit. That's disgusting. It could be that whatever you're smelling could be giving off chemicals that could cause you to become sick, that could be dangerous to you, so you want to avoid that. Another example, a lot of times whenever you pull the milk out of the refrigerator, you're going to smell it before you drink it to make sure that it's not soured. So anyways, those are just examples of how unique the sense of smell is. The last sense that we're going to talk about is our sense of touch. So our sense of touch is going to give us information about temperature, you know, hot or cold. I'm freezing today. I'm not going to complain because it's better than 112. It also gives us information about pressure and pain. So there are all sorts of sensory receptors located on our skin. You have your hair cells that are on your skin that gives you some information about what you're feeling. And then you also have pressure sensitive nerves right under the skin, and pain sensitive and touch sensitive free nerve endings. But before we go on to talk about, and that's your basic sense of touch. But what I also want to mention here is that pain is very psychological. So maybe you have been told in your life that you have a high pain tolerance. There are different types of pain. There are quick, sharp pain that tells you maybe, you've broken a bone, and that quick, sharp pain tells you don't use your arm anymore because you just broke it and you can do further damage. And there is that just, like aching, the body aching, and that just tells you, you know what, something's going on here. We need to get whatever is going on checked out to make sure that you don't get further injured. So, but remember, and we will talk about this again in chapter 4, pain is extremely psychological. So a lot of times it can be mind over matter when it comes to pain. And I'm telling you, in this class, we are just skimming the surface of, why we do what we do, feel what we feel, and think what we think. But our bodies and our psychological well-being, it's all very complicated. So why is this sense of pain very unique? Why is it mind over matter? Well, it could be that you are experiencing a lot of emotional pain at a time in your life, and then you just very mildly bump your head and you feel like that hurts so bad when, at another time in your life, it wouldn't have hurt quite as bad. And that could be related to actually the emotional pain that you're going through. So then, like when we get to chapter 14, and we're looking at psychological disorders, we can see how the sense of pain could be related to like a hypochondriac or somatoform disorder or something of that nature. because a lot of times we might turn our physical pain, take all of our emotions and turn them into physical pain instead of that emotional pain. So like I said, you're just barely skimming the surface, but there's so much going on here. Okay, now that we've talked about all of the senses, let's look a little bit at perception. Okay, the first thing that I want to mention when it comes to perception are constancies. There are 3 types of constancies: size constancy, shape constancy, and brightness constancy. So if we look at the raw data, what the image, the light energy that is falling onto our retina, that might be different than what you actually perceive. Okay, so let's take my phone. I want y'all to just tell me what shape my phone is. What shape?
Rectangle.
Yes, Ace, a rectangle, okay? Now, when I turn my phone sideways, you see a different shape. Did the size or did the shape of my phone change?
Now it's a stick.
Now it's a stick, but did my phone actually endure a change of shape?
No.
No. We know that because of experience. So our constancies are based on experience. So even though we see a different image, on our retina, we know that the phone did not change shape. Okay? Same thing with color and brightness and size. When a car is driving away from you, the image that it is portraying on your retina is getting smaller. But we know because of experience that that car is not shrinking. Okay, that's size constancy. So constancies are important when it comes to perception. And then we also look at Gestalt principles. Okay, Gestalt principles, we talked about Gestalt psychology, Max Wertheimer back in chapter 1. So here are some examples of Gestalt principles of perception. Okay, so like proximity. When we look at these different lines, we see things, we perceive things that are a little bit different than the actual raw data, okay? So how many groups of dots do you see in this first line?
3.
3. What makes it 3 dots? Why is there 3 groups and not one big group?
The amount of spacing between the 3 big clumps.
Yep, proximity. So that is a principle, Gestalt principle of perception. Here, same thing. We tend to group similar things together. So instead of seeing one big group of dots here, we see 5 groups of dots. 3 red. Somebody say something? Okay, 3 reds and 2 blacks. Okay, so here we see a circle and a square. Even though there's space between these lines, our brain automatically closes those together. So you can see how Gestalt principles of psychology work. Now remember from chapter 1, the Gestalt psychologist said that the whole is greater than the sum of its parts. So that tells us a little bit about how we perceive things in our environment. One other thing that we need to look at when it comes to vision is depth perception. So there are 2 ways that we perceive depth, okay? Monocular cues use one eye. So here are some examples of mono means one, monocular cues, okay? So the, oops, sorry. Linear perspective, if you're driving down the road and you know there's 2 parallel lines, as they come together, you know that that's further away. Okay, so here are some other things that ways that we perceive depth perception with just one eye. And the texture gradient, you can see more texture to things that are closer. Relative size, since these flowers are bigger than these flowers, you know that they are closer to us. And then here is the aerial or atmospheric perspective. Things that are further away have a tendency to be hazy. Those are all different examples of monocular cues of depth perception using one eye. But we also have binocular cues. The first thing is convergence. So everybody take your pen or pencil, if you have one with you, and look at it and move it to your nose. What happens to your eyeballs as you look at your pen and move it to your nose?
They cross.
They cross, they converge. When your eyes converge, it tells those muscles in your eyeballs tell your brain that the object is closer. So if it's out here, we know that it's far away. But as we move it closer, our eyes converge and we know that it's getting closer to us. The second, somebody's microwaving something. Whoever's microwaving something, you want to mute? Because this is making me hungry. That's so fun. Aren't these Zoom meetings
I'm
fun?
not playing them all myself.
Okay, so the second type of cue, binocular cue, is called retinal or binocular disparity. So I know all of you do this or have done it at some point in your life, so you can't think that I'm crazy. But sometimes when I'm laying down on my pillow, I will close one eye and then I'll close another eye. And I see two different images of, the blanket or whatever's in front of me. The difference between of what your two eyes see is called disparity. So if you're looking at something really far away, I know y'all can't see it, but there's a black car way out there in the parking lot. If I close one eye and then the other eye, the image isn't so different. But if I were looking at these keys right up next to my face and I close one eye, then the other eye, the difference is pretty big. Like I see totally different keys out of each eye. That is called binocular disparity. So we use binocular cues and monocular cues to determine depth perception. Okay, what about these things? These things are probably going to bother you. I told you, or whenever we're looking at perception is very unique and based on experience, but some things trick our minds into perceiving something different. So one of those is this. What do y'all see in this picture that's odd?
The gray dots, they're like coming and disappearing.
Yeah, the gray dots. They're not really there, but a Hermann grid is an illusion that causes us to see things that aren't there. This one's always fun. If you're looking at these two pictures, which one is longer?
They're the same.
They're the same, but doesn't this one look longer?
Yes.
This is the Mueller-Lyer illusion. The moon illusion, I don't know if you've ever noticed, but if you ever go outside and the moon looks huge and it looks like it's just right, it's close to Earth when it's on the horizon. But as it moves up in the sky, it starts to shrink. That's something that we all experience. There's so many different, oh gosh, I don't know if I can show y'all these. Y'all see all the moving parts?
Yes. Oh, I hate ones like these.
I know, I do too. Here, I'll change it real fast. This is the Ames illusion. It shows you this little boy looks bigger. There used to be, I haven't been to Six Flags in a couple of years.
Oh, it's making me sick. Look,
I know.
yes, I have a sensitivity to them.
Yeah, me too. I don't like them. If you've ever been to Six Flags, they have a room that's tilted like this. And it, causes things to look distorted, and it's an illusion. In the Ames room, this boy looks bigger than this man, but it's just because there's a slope here. Okay, so the last thing that I want to emphasize before we stop the chapter 3 lecture is a perceptual set. A perceptual set is based on your experience with the world. So you can kind of interpret a perceptual set into like a stereotype. Perceptual sets are based on experience, and they allow us to work more quickly with the world, okay? So sometimes we use either top-down processing when we look at the big picture and we come up with the details. And sometimes we go with bottom-up processing, where we take the details and we come up with the big picture. And these are all based on our experience, our perceptual sets, and how we deal with the world. So it's important, we've gone with all of the ins and outs of everything today as far as sensation and perception, it's very important to remember, the most important thing that you can remember about today is perception is based on experience, okay? So, trying to make sure I get everybody for roll. Okay, so does anyone have any questions, comments, or observations for chapter 3?
Like you were talking about earlier, I'll be like just asleep and then like I wake up in my room and I always think like something's there. It's so weird.
Oh yeah, I've had that every single night. It's where like there's a shadow in my room, and sometimes like one night there was a dent in where my Penny always sleeps there. My dog always sleeps with me like a toy poodle. And one night, then the corner where she always sleeps on the edge, it felt like someone sat down and was staring at me all night. It like freaked me out. Long story short, I ended up sleeping with the Bible.
Who's sleeping with the Bible?
Me. One night. It freaked me out so much because it felt like someone was watching me. And it felt like someone grabbed me, but the next morning I woke up, I had 3 scratches on my back.
Oh, yikes. That's scary. I don't
So
know.
I don't know what I did in my sleep, but
Someone was trying to get into our other classroom. So just for your information, if you ever do, if this is working for you and you don't need to come into the classroom, then that's cool. Nobody is in front of me today, and that's totally cool with me. But classroom number 7 is usually locked, and I have a key to nearly every door in this building except for classroom 7. So I am in classroom 10, and this is where I will be studying most Tuesdays and Thursdays. There will be some days that I will have to do the lecture from home. Like yesterday, I got halfway to Abilene, and then I was just like, we're driving 40 miles per hour in this rain, so I just turned around and went back home and worked from home. I didn't have any classes yesterday, but so if Zoom is working out for y'all and nobody's having any problems with it, then let's just continue to do these Zoom meetings every Tuesday and Thursday. Next Tuesday, we will be going over chapter 4, and the next Thursday, we will be reviewing for test number 1. So, and then the next Tuesday, we will not meet because you'll have a week, I'll give you like a day off from class to take your exam. So I will go over all of those details next week. So our next scheduled Zoom meeting is going to be Tuesday at 8. If you are, now this isn't going to apply to any of y'all that are here with me today, but I am recording this and I will post it on the homepage of our class. So here in just a little bit, I'm going to take chapter 2 down and I'm going to put this up for chapter 3. So if you go back and watch something, if you are not sitting in front of me live in class, like a lot of you are, and you have to go back and watch the video, always email me to let me know that you watched the video so that I know that you're keeping up with the lectures and things of that nature. Okay, so chapter 4 on Tuesday. I hope that you all have a fantastic weekend, and I will see you then.
Bye.
Bye.
Bye, everybody.